Hi, I'm Jack Buffington for RobotBrigade.com. This is another video in my series of videos about digital logic. And this one I'm going to talk about a kind of an interesting circuit. It's called a linear feedback shift register. And what this is this is a type of circuit that creates a output of maximal length. And what that pretty much means is that if I have, say, 5 bits, or we'll say n bits, what it does is it produces a sequence of numbers. It's sort of a counter that gets all 2 to the n except for one of them. And that one number is 0. So if I have a 5-bit counter, that will give me 31 different values out of it. And why that's useful is because they're not counting in any particular order exactly. They're pseudo-random is what it's called. And this is very useful in a lot of situations where you want a number that could be random. And so you might have this circuit just running all the time, counting in its special order. And maybe when a user pushes a button, it checks this value and gives a random number, which really, if you have this thing running quickly, it really will be random because there's no way that you can repeat the button presses in the exact right timing to get the same random numbers every time, though it isn't truly random. Anyway, let's look at how this works. So what you're going to have, let's do an 8-bit. You're going to have a serial in, parallel out shift register. And you need to make sure that it also has a load function, because if you start out with this in 0, it's just always going to put out 0. So you need to make sure that it has something that it started up with. So whatever that might be, you have it so it can load it in. And you have your serial in, and then coming out of your outputs, so we'll call this one 0, 1, 2, 3, 4, 5, 6, and 7. With an 8-bit linear feedback shift register, what you have is you have exclusive OR gates, 4, 3, 2, and 0. And then these feed back into the serial in. And you're going to read your pseudo-random number out of the outputs here. And that's really all there is to it. You just have to have a clock to tell it when to increment. Now, I'll give you a couple others. For 16-bit, you are using 5, 4, 3, and 0 as your exclusive ORed together. And for 32-bit, you're using 22, 2, 1, and 0 as your inputs to the exclusive OR. And I don't know a huge amount of math, but apparently there's a theorem out there that says that for any number of bits, there are, you can find a sequence where you can find a certain number of bits, it's not always 4, that will give you a maximum length number generator if you just exclusive OR them together. So there you go, linear feedback shift registers. They're very useful for pseudo-random numbers. I've got a project, I intend to follow these up with a series about FPGAs, and I intend to use one of these in one of the projects that I'm going to show for that, and I'm going to use it to generate white noise. So, alright, well, if you enjoyed this video, or at least found it useful, take a look at my YouTube channel where I have other videos like these about digital logic, or visit robotbrigade.com where I have a master index of all of them.